So let's switch from library development to a more application point of view. Totally. This is a project to collect all the OGC web services. We start with Switzerland, of course. For those who, I think everyone knows what OGC web services are. Anyway, we concentrate on map services, feature services, and map tile services. And we exploit the GET capabilities requests to collect the metadata as XML. But why to develop a search engine for those geodata or web services? We collect all this data with a scraper. So in Switzerland, we scrape all the servers. And as you can see, those are the bounding boxes of all these layers. And they have some spots. So there are some concentration in some areas of Switzerland. And those are the cantons of Switzerland. So that means each canton has web services. So there are a lot of providers in Switzerland. Each provider has its own system to develop the services. Of course, there is a standard for it. There's standard, so OGC standard for the development. But as you can see, some of them are using one service endpoint and for each layer, and others are just putting all the layers in one service endpoint. You can connect the service endpoint and retrieve all the data. As you can see on the top, this Canton Freiburg, they use one service endpoint for each web service, which can be complicated to integrate. Basel City on the bottom right use just one service endpoint with all the layers, which can be sometimes useful and sometimes not. Anyway, there is always different implementation of these kind of services. So with this project, we try to develop a single entry point for all these services, which collect all this data, and it's a user-friendly system to search all this data. It's a collaboration with the Federal Office of Topography here in Switzerland. Down here you can see the architecture. So there is, of course, a front end, which is developed in TypeScript and React, no Python there. But it interacts with the backend, of course, with REST API implemented using Fast API. And the backend is built into 2 Docker containers for a faster deployment. One contains the database, the Redis database, and the other one, I will come to it in the next slides. And the other one contains the engine, the search engine, on all the functionalities, for example, the scraper and so on. The scrapers works as separate tier of the system, so it has no dependencies to the search engine. Yeah, of course, the front end is needed for the users, but I won't spend much time on it because we focus on the backend in Python. Starting with the database, we have chosen Redis because it's NoSQL, so it has a very good scalability of the system, so we can add additional data. We have no constraints like with SQL databases. It's an in-memory database, so it means we don't need a lot of space on the disk, on the hard disk, to store the data. It's just in-memory storage system. Of course, we just retrieve metadata, so it's not that much space. Of course, open source, and of course, it has a Python interface. There's some drawbacks. Yeah, the query function are limited, so you have to implement your own query function if you want something special. The documentation for the Python interface, it's not that well written as many packages, unfortunately. And the output format, it's also quite limited. Well, let's move on the scraper. The scrapers scrapes, of course, these servers, and it looks for this kind of web services. And it's based on a proof of concept from Swiss Topo, and it exploits OWS lib, which is a library for this kind of services, where you can exploit the get capabilities request to collect the metadata, and then retrieve all the metadata that you need, so the kind of service, the layer that it contains, and so on. The scrapers also compares during the process, compares the already extracted OGC web services with actual one, so it avoids double entries, and it's also store the data in a pandas data frame. Of course, geodata, but it's just a metadata, so pandas data frame, it's enough. And we automated all the process, the whole process in with a GitHub action. So on a GitHub repository, there's the possibility to automate everything. Then after we collect the first round of the data, we look into them, and we find out some challenges. Here's a list of metadata that we use. In green, you can see the fields that we can use for our search engine. So we say, okay, we look into these fields to search for something. And then comes the first problems. So let's say keywords should be the perfect field for the search for something. And as you can see, most of the providers left the fields empty. So we can use the keywords, and in addition, those keywords that are filled is usually an average word count of 1 or less, which means that it's just a link to maybe to a geocatalog, or in worst case, it's an NA or NAN text, and you say, okay, I can use that. So we switch to the abstract, which is a description of the layer. And okay, now we have a bit more data, but the problem is sometimes a very long text, and we need just a few words to index them, just to put them into the search engine and exploit them for a search and to do it fast. So now it comes a pre-processing step into play. So we extract the information from this text using this pre-processing pipeline with natural language processing. So in the first step, we use this rapid automatic keyword extraction to extract some the most important sentences of the text. And we refine them because Rake is a very simple graph-based method without any machine learning or deep learning implementation. So we refined then the results, which were sometimes a bit weird. So we refined them using a deep learning model, so this sentence BERT, which is based, of course, on neural networks. And we refine these words, and we also tokenize then the results using grammatical analysis, exploiting the package SpaCy, which is very useful to analyze the grammar of the sentences. Of course, also this step were automated with a GitHub action. For those who are not familiar with natural language processing, this is what SpaCy do. It's just analyze the grammar of a sentence, and you can retrieve all this kind of information and decide which fields you can, if it's stop words, if it's verbs, and so on. So you can just keep what you need and implement on it other functions. So in the pre-processing, we also implement lately multi-language support. As you already may know, in Switzerland there are different languages. So there are 4 official languages, which is French, Italian, German, and Rätoromanisch, yeah, that one. But of course, we want also English. So we implemented 4 languages. We use, of course, Deep Translator API to automate everything. Of course, was a lot of entries to do it manually. Yeah, sometimes the results are quite good. Sometimes they are not that good. So they need to be just checked, sometimes manually, because the translations sometimes are not that good, in particular for very short texts. And of course, we integrate everything. So we create additional columns in our database, and we integrate everything in the front end. So we could search in all languages. So in the front end, you can choose the language that you want, the interface, and then you search in that language. About the REST API, yeah, it has standard functionalities. So it loads the database on startup. Of course, it's an in-memory database. So on the startup, you have to read the data. And it also searches the data in the database and rank the results with a ranking function, and also paginate the results for the front end. About the search and ranking function, the search function exploits once more natural language processing. So we first use tokenization, stop word removal, then stemming, and then we implemented these ranking functions, very simple implementation. We will for sure improve it, but it searches for stemmed and not stemmed words. For stemmed words, it searches just for similarity matches, and for not stemmed words, it searches for exact matches. So if I search for a word and it finds exactly that word, then it will give more points to the ranking score. And in this way, I can calculate a ranking score for each entries and then rank my searching results accordingly. So the results, you can see here a preview of the user interface. Of course, it's a user-friendly single point of entry for web services. There's also some additional functionalities, so you can download directly the link for the integration in, for example, in QGIS or ArcGIS for the fun of Esri. We improved the data discoverability using this NLP extracted information by 30%. And we also improve the results ranking in almost all the cases. So that means the results were positioned first. So the result that I wanted were in the first positions. Of course, we have a lot of work to do. So we will for sure improve this ranking function, in particular the performance, because the ranking function, we have to apply it each time that the queries start. So it will take a bit of time for each queries, in particular for very long queries. Some people look for a whole sentence instead of just 2-3 words, but yeah. We will exploit the spatial relevance of the queries, exploiting the bounding boxes of the services. That means I can compare the footprints, what I'm looking for. So I can, from the queries, I can extract, for example, a place. When I'm looking for example, data in Switzerland, so I will extract Switzerland and I have the footprint of Switzerland, and I will compare this footprint with the footprints, the bounding boxes in the database. An additional step will be the classification of these web services. As you may know, there is these Inspire categories, which can be helpful to split the results into categories and have a more comprehensive overview of the results. And of course, for the moment, just data in Switzerland, because we have access to the Swiss servers, but we may in the future expand it to other countries. I'm really come at the end of my presentation, and if you want to check the GitHub repository, it's all open source. So you're welcome, and thank you.
Thank you very much. Are there any questions?
Have you had any luck with getting the cantons to improve their data by showing them the results that you're getting?
Canton?
Have you had any luck getting the cantons to improve their data, their descriptions, because you can show them what you're getting out of it? Or
yeah, we are working on it. So we will give feedback to all the service providers, and we will say, okay, you are just describing your data in this way, but it's maybe wrong, or the other canton is doing it better. So just to challenge them to do it better.
Maybe like a findability score or a ranking table, and you show them the table.
Yeah,
and
we have actually we have we have calculated a kind of metadata quality score. As you can see maybe in the other slide, metadata quality is just a simple calculation on which fields are empty and which are not, and it calculates the score. It's just to push the providers to do better with the metadata.
More questions? Yeah, I will come around.
Thank you very much. Looks very promising. I hope you go to Germany as well. Do you have an overview? Who are your main customers who is using your service mostly?
We don't have this kind of statistic yet, but for sure we will collect also this kind of data. The problem there is also all the privacy and this kind of stuff that it's always complicated, but yeah, sure, it will be a point to work on.
Hello, thank you for the talk. Is there a public URL in which I can see GeoHarvester, or do I have to run it myself?
Yes, there is one. The problem is the moment it's offline, because you have all this kind of problem with server license and so on. But it will be back online in, I hope, few days. There is a link in the description on the GeoPython website.
Congratulations for the nice work. I would like to better understand what it brings on the top of GeoCat and how does it communicate with GeoCat on OpenData.Swiss?
At the moment, we don't communicate with GeoCat because yeah, it's complicated. So some providers just put the link to GeoCat, but it's a general link. So you go to this link and you get all the geocatalog, the whole geocatalog, and you say, okay, now what's I'm looking for? I don't know. So we will talk about it with the providers, and hopefully they will give more detailed information about this link, because at the moment it's not usable.
Okay, one last question.
Do you have any plans for including the support also to OGC API family of APIs?
Yeah, that's the good question. We don't have planned it yet. We have our hand full at the moment, but yeah, we could think about it. Yeah.
Okay, thank you very much again. We have the opportunity to have more questions. Now is the coffee break. We have 30 minutes time and the next talk starting. Thank you very much again, Elia.